Hey, can everybody hear me?
Good morning. Yes, Ned. Thank you.
So I didn't see Mohammed's slides that he's proposing. I'm in the process of trying to approve.
Yeah, hello. I proposed at around 11 a.m. Germany time.
I
Okay.
approved 2 decks this morning before everybody else was awake. Those were the
Okay.
ones I saw.
Could you
Okay.
please check whether you have, I see that the mail was sent to the Reds chairs and a copy to me, also the area chair. So hopefully you should have got the email as well.
Huh. I don't see it. Let me check in my spam folder.
Yeah, probably.
Hello? Testing 1, 2, 3.
We can hear you, Ned. Can you hear us?
What's the title for your slides?
Sorry, what time are you saying? Are you
What's the
asking?
title? The title?
Okay, so the title is, I changed the title a little bit because I found that Michael is probably going to talk about what I propose to talk. So the title is Can Rats Architecture Help in Security Analysis of Attestation Frameworks?
Okay, so can you post them again? Because I'm not seeing them as well. And I approved a bunch of the slides. I don't see anything in queue to approve.
Okay, that's strange. Okay, I will
Yep.
then upload again. Okay.
Thank you.
Okay, I think
Go ahead, Ned.
I got my audio working. Yeah.
Got
So did
That's good. Got it.
did Osama get his slides situation resolved?
He's going to post them again.
Okay.
Ned, did you also not get my email in the morning today?
Not.
That should be your evening, but
Yeah. Let me see if it's in the queue.
You know what? I see them now. Let me see.
okay, perfect.
Yep, so now they're approved. I'm sorry. I thought I had gotten all of them this morning. They're approved now.
Okay, thanks. So I'm not posting them again now. Thanks.
No problem.
Okay. So we're kind of already into the start of this, so maybe we can kick it off. Before we get started, we need a couple of volunteers to take notes. Speak up if you can take notes, please.
Ned, I volunteered on the mailing list, so I'm here.
Okay, great. Thanks, Thomas.
And Usama as well is.
Usama is going to back up. Okay.
Yeah.
Great. Thanks, Thomas and Usama. All right, let's move on. So here's the note. Well, just a reminder to familiarize yourself with the rules for participation in IETF. And a reminder about the code of conduct. Just be courteous and respectful. Keep your discussions impersonal. And we got that already. So, and here's our agenda. So we plan on having these talks. We have about 5 minutes remaining. Are there any changes that we want to make to this agenda? Sounds like not, so we'll move on. And then there's some material. I think everybody's familiar with where the materials are. So I think that's it for the chair slides. So we'll move on to our agenda, which would be Michael Richardson. Remind me again what your slides were, Michael.
This is Henk. I think Michael temporarily disconnected.
Do we want to switch it around then? Maybe go to the other topic?
And his slides are in the queue. But yes, I think that makes sense if he's not.
Yeah,
Given that we're short on time, we should move on.
Yeah. Okay.
He's
so
back.
Let's go. Move on to the next topic: attester groups for remote attestation.
Hello, can you hear me?
Yes.
Yes. Okay. Okay. So we will present the draft for the attest group for remote attestation. So next page. So the motivation is that so in the systems, in some systems that exists a high number of homogeneous devices. So we want to reduce the computational and communication overhead by enabling a collective evidence appraisal attestation. So therefore improve the scalability of the remote attestation progress. So in these figures, there's examples that if you have millions of devices that similar with similar architectures, if you do the individual attestation, it will cost a lot. And we want to create a attester group to just attest the group of these attesters. So we want to propose an extension to the current remote attestation procedures defined in IFC 9334. And the next page. So in this page, we show two possible use cases, which large-scale networks that we contains the device are homogeneous with similar characters. So the first application is the remote maintenance in the aerospace domain, which is in the project of Euro Assured 2020. So the goal is to attest the millions of aircrafts that we need attestation of all core PLCs and embedded systems responsible for the core functions of the aircraft. And the second use case is for the automobile domains. So a vehicle with embedded electrical control units. This is in the context of the Connect European project. So in this case, that in our automobile vehicles, there exist many ECUs. So with the similar architectures. So we want to have the attestation for the group of these ECUs to reduce the overhead. And we can consider the attested group or a fleet of 30,000 vehicles with the same brand. Next page. So in the IFC 9334, they have defined for each attester, they have defined the two environment, which is the target environment and the attesting environment. So along the basic mode, they are talking about the two kind modes that we have for different evidence to combine. One is the layered attester mode, so that you need to do the attestation from bottom to top, that the bottom layer provide attestation environment for the upper layer. And this is not fit for the cases that you have many units that have the similar structure because they are independent to each other, that they do not exist a hierarchical relationship. And another case is the composite device, so that you have a leader attester that it received the local claim and collect the evidence from other sub-entities and combine these evidence and with its local claims to an aggregated evidence and send it to the verifier. And there exists tunnels between the leader attester and the verifier, while the other entities may not have such kind of a structure. And next page. So we are sure that the composite device actually does not fit for our target for the attester of a group. So this is we have listed tables to show the difference. So in the composite device, there exists one leader attester, and we expect that in the attest group, there's no leader attest, means that there can several nodes connect with verifiers, or it can be do in the distributed way. And in the composite device, the composite device is identified by the leader attester, and while in the attest group is identified by the group ID. And in the composite device, the composition of the evidence is based on the submodules, and because in attest group, all the devices in this group have the similar architectures, there's no composition of the evidence. Next page. So we find that there's several places we can add these extensions to the document in the RADS. So in the RFC 334 section 3 architectures, we propose to add one subsection 3.4 titled attest group. And in the draft attesting results for secure interaction section 2.2, no readability. So we propose to add one entity type group ID. Next page. So we think that we should make use of the similarity between attesters to avoid redundant attestations. So the attest group is defined by the dynamic entity, and attest can join or leave this group. And we need to define a new mechanism, which is not necessarily based on the composition of the evidence. Thank you.
So thank you. I have a few questions. This it's of a similar theme to what I had called attestation sets, and now is called posture assessment. Both drafts are going after scale in two different ways. I think we need to sync on this, and I personally think it's fine if both methods are represented, but it might be that if the working group likes this approach, that perhaps we figure out a way to do that within one draft, or we have a relationship between these two drafts. So the posture assessment draft goes after it a little bit differently in that the assessment can be done locally to a defined policy set, and the policy set is registered, and you can just send a simple remote attestation saying that policy was met or not met. And so you're getting the individual assertion or list of problems in a scalable way, as opposed to sending the full data set over for every single entity. And in your approach, you're consolidating it down. If everything looks good, you're just sending one set of full evidence, right? So
Yes.
there are two different approaches to scale. So I think we should sync and figure out, and then also hear what the working group thinks.
Okay.
Any other discussion? Okay, so let's move to the next topic. This is, again, June.
Okay, so the title of the draft is Handling Multiple Verifiers in RAS Architecture. Next page. So in this figure, you can see the information flow in the RAS that the attester send evidence to the verifier, and the verifier send a corresponding attesting result to the reading party. That we have one attester, one verifier, and one reading party. So we think that single verifier may face the problem of single point failure, that we need to augment the RAS architecture to provide multiple verifiers. So we will have some challenges in terms of the scalability and robustness. So our goal is to acknowledge and address potential inconsistent behavior of verifiers by aggregating attesting results collected from multiple verifiers at the reading party and simplify the policy and operation. Next page. So we are sure that the current RAS architecture may have some problems to deal with the multiple verifiers. So we start from the passport mode. The first case is that the attester does the attestation in vain because the reading party does not trust the attesting result from the certain verifier. Because in this case, for example, the reading party does not trust verifier A, while the attester only have the attesting result generated by the A. And the second case is that when the verifiers can generate different attestation results based on the same input of the evidence, the attester can cheat by dropping a certain attested results that it does not like. So it can selectively send the attesting result to the reading party. In the background check mode, we also show two possible cases that may have some problems. The first case is that a trusted verifier may be compromised or not available, so that the reading party will not receive the correct attesting result from the verifier. And the second case is that when the multiple verifiers may have inconsistent behaviors, means that they will generate different attesting results from the same input of the evidence, then this will create the conflicting of the decision at the reading party side. Next slides. So we propose to extend the background check mode to handle multiple verifiers. That one example is to extend the current background check mode. So we will introduce the multiple verifier to ensure the resilience of the attestation service. So the extension is basically on the reading party side. So it will be the reading party who initiate the attesting flow that will generate the request for the attestation and generate the corresponding nonce. And when it gets the evidence from the attester, it will forward all these evidence to the recommended verifiers, which will be explained later. And when it gets the attesting result from all these verifiers, it will do a great attesting result to make its own decision. So the benefit is that because in this case, the attestation result from the verifiers is always accepted by the reading party, so the attestation is not done in vain. And we can also ensure the availability and the security of the remote attestation based on the wisdom of the crowd, because we have more verifiers to make the decision. And so in this case, the attester only need to send one evidence to avoid the redundant generation of the evidence. And we do not need to contact all verifiers in this case by the reading parties, which is detailed in the verifier manager part. So next page. So we introduced the entity of the verifier managers to support the flexible verifier configuration at the reading party side. So this is the interaction between the verifier manager and the reading party. The reading party will send its seed anchor verifier list and the number of verifiers that it wants to the verifier manager. And the verifier manager will match these verifier list with its local verifier list group and find the matched one and send back to the ring party, which is called the recommended verifier list. And in this case, the verifier only contact the recommended verifier list rather than all verifiers. So, and also in this way, by change the seed anchor verifier list at the ring party side, the ring party can flexible change its local policy. Next page. So we will show some use cases based on this extended model. The first case is the node attestation for trusted routing. So in trusted routings, it requires that the traffic goes through the trusted nodes in the network while the nodes is attested by the verifier. So this is one use case is shown by the NASA BOF group. And the challenge is that the single verifier may not be available and may be compromised. So we provide a solution that will provide the multiple verifiers, called primary verifiers and secondary verifiers. So to ensure that the attesting verification service is always available for the nodes in the network. Next page. So the second case is attestation in the data centers. So in the data centers, we have units like the CPU, GPU, and data processing unit. So they need to appraise each other to guarantee the trustworthiness of the workload in the unit. So each unit may be appraised by many other units. And this will result in large amount of requests for the evidence from each attester. So we want to address two challenges. One is that to handle the case that in certain cases, the verifier does not work. And the second case is to reduce the number of evidence to generate. So following on the model, we can use one unit as a tester. He will send another unit as the railing party. We will send the request to and announce to the attester and get the evidence and send forwarded evidence to other units and get the attesting result from these verifiers to have aggregated attesting result and send back this aggregated attesting result to other units. In this way, it will prevent the dysfunctions of certain verifiers. For example, even the verifier at this railing party does not work, still it can get the attesting result from aggregated attesting result from other units. And we guarantee that one evidence is sufficient to fit for the verification for n units. So that's all for the presentation. Thank you.
I don't see anyone in the queue. Usama?
Yeah, just a clarification question. Maybe I missed something, but on slide 4, I think you were showing various verifiers. And yes, exactly. So is it the case that the relying party will in parallel send this evidence to all the 3 verifiers? Is this correct?
Yes, the railing party need to send the forward. Actually, it forward the received evidence to all these shortlist verifiers.
Okay, and then it has to wait for all of the verifiers to send it back the attestation results because there might be a different kind of latency between these verifiers.
Yes, and so whether it need to wait for all to collect all the attesting results or not depends on the local policy of the railing party. So, for example, if it is say that five attestation results is sufficient to make the judgment, so it can do not need to wait for the other attestation results. So it all depends on the local policy of the railing party.
Okay, so you are saying that the step 5 is basically dependent, the aggregation of the attestation results is dependent on the
Yes,
policy.
yes.
Okay,
So
right.
I left it open for the aggregation algorithm and the policy.
Okay, right. Thank you.
Hank?
Yeah, I'm in the train. I hope this works. I do not know. There were questions in the chat that should be repeated. I don't think that June saw them.
Okay. Is there interoperability issues that need to be taken into account with approach? It looks like implementation strategy to me. Hand,
So I
can you
think,
explain it?
so I say, I don't know. So I can repeat Erie's question as I don't know why I'm doing this. Simplifying policy is a quote from you, question mark. Wouldn't each verifier still need a separate appraiser policy?
So here, for me, to simplify is that so for the ring party, you just need to configure the anchor seed list that is already sufficient to specify its policy, that what kind of appraisal policy it prefer.
Yeah, but it still needs to be distributed to each verifier. It can't be uniform per verifier.
Yeah,
Or
I mean
it should
that.
be.
So yes, for each verifier, so they can have different policies. That for the ruling parties, so we just configure the preferred anchor seed nodes is already sufficient to show its preference for the policy. So that does not need to list all the details of the appraisal policy.
I think you've got a very specific implementation model in mind. Then it's sort of similar to what Hannes mentioned, because there could be situations where the relying party wants to actually have results tailored to something a little bit more customized on a verifier by verifier basis. So I think what you're thinking about is that one verifier manager, if I understand this correctly, would actually take a single input from the relying party and be able to disperse different appraisal policies to each verifier. Am I correct?
Can you repeat your question?
Yeah, the relying party contacts the verifier manager, correct? And then the verifier manager is the one that's responsible for dispersing different appraisal policies to each verifier.
Yes, yes. Actually, you can think of the verifier manager as one kind of like the DNS in the internet that they are doing a database job. They that classify the verifiers into different groups, and we will find a match between the intended verifiers to recommend the verifiers.
Okay, then I don't really think you end up simplifying appraisal policy, then unless there's something that's gone terribly wrong with this model, because you're still having to distribute a separate appraisal policy to each individual verifier, so you're not getting any efficiency gains from that perspective.
Well, I mean
Okay.
that the verifiers can different verifiers can implement their own appraisal policies, but the verifier managers will, according to the behaviors of these verifiers, to group these verifiers into different groups, and then for each input of the anchor seed verifier list, he will send the corresponding matching verifiers to the ruling party.
Kata has a clarifying question in the chat. Says, is the same evidence that is sent to all verifiers, or the relying party will transform the evidence depending on the verifier?
So currently we will not think of the ruling party will transfer the evidence, so it will be always the same because it's the same evidence sent to the ruling party. So it depends that the verifier, if the verifier accept different format for the evidence, yes, maybe you can implement such kind of functions to translate the evidence into different format.
So in your slide 3A, 3B, 3C, that's all the same message.
Yes.
But 4A, 4B, and 4C, are they different results?
So it depends, because according to the verifier manager, actually he will recommend some verifiers that share based on past behavior share the same standard. But there are some cases that if it is get compromised, the attestation result from the ABC may be different.
Okay, Kathleen's on the queue.
Thank you. So while this is the right group for attestation, since there's a big impact on routing, I don't think we're the right group to adopt this particular draft, because we really do need routing and networking experts to be able to weigh in on this, even though, you know, if this approach goes through, there will be people from this working group that would need to participate to help on the attestation and verification piece. But there are pretty big implications for the network. So I think a wider audience and a slightly different audience is needed to support the direct development of this work.
Hannes is on the queue.
Hi.
Can I ask a question? Kathleen,
Sure.
I don't understand your point. Do you hear me?
Yes.
Yeah, there's
Did you just say you don't understand my point?
Yes, because you said this proposal is not suitable for this working group.
Right, because of the impact to the network, right? We could get this through and have all the attestation pieces correct, but this group does not include, I have some routing experience, and, Nancy works at Cisco, so she obviously has some, but you really want network operators involved in the review of the approach for this particular draft and how it would integrate with the network. And then, as a former AD, I personally would have rather see this in, let's say NASR becomes a working group in NASR, and then you invite in the participation of experts from this group for the attestation piece, but then you're making sure the broader implications on what this looks like in terms of impacts to the network are addressed by experts in that area.
But I agree with you, there is a link with the network, but we can also consider, for example, for the second use case that we propose, we are not linked directly to the network. There is communication between the element in a system, and there also we need to resolve the problem of if the verifier is not available or compromised. So the multiple verifier will be, it's part of the architecture of RAT in our thinking. Maybe we are wrong.
I don't know.
Yes.
Yeah, so this is Nancy too. I'm trying to look at the charter, but I'm being a little challenged with my Wi-Fi. I don't know that this is necessarily in scope for the charter, especially looking and listening to how they're proposing the notion of having multiple verifiers and how the communication flow comes in. And I think that's where Kathleen is saying there's some networking components for how that communication flow, whether it's routing or, well, routing, how you forward these come into play is where we need to have that conversation as well.
Okay.
But to the earlier question and comment is, right, again, some of this to me feels like it's more implementation specific as opposed to the actual attestation.
Hannes is on the queue.
I was wondering about the different verifiers and their relationship to each other. Is it mostly a deployment where we, like in a web server context, where we create multiple microservice instances of the same functionality, and so we have some resiliency in case in one microservice, in this case the microservice implements the verifier functionality, crashes, and we just basically then have other instances that can respond to? Or are we really talking about sort of like totally different administrative domains? Like the difference between the A, B, and C didn't make that sort of clear to me.
It's different. Yeah.
So they are different because One thing that because in the discussion in the mailing list, so people are talking about that maybe we can have a super verified to distribute all the load to other verifiers, but still you will have the same of the resilience problem if you create such a kind of super verified. So we're seeing that in this case, in certain cases to guarantee the availability of the attestation service, so multiple verifier is needed in this case, and it's not mentioned well in the current IFC document.
Yeah, but it doesn't answer sort of the question, because like it also relates to the policy question, because if it's the same party just deploying different verifiers, that makes it easier to also synchronize the policy. But if the verifiers are like coming from totally different parties, like Intel is deploying one and ARM is deploying another one, and let's say Deutsche Telekom yet another one, how do you make sure that the policies is sort of sensible? Because then you get, if they are not somehow synchronized, you run into all sorts of problems. One problem would be checking for freshness. The next problem is like having the right reference values, the right trust anchors, and the right endorsements, right? Otherwise, because the values that you then get back, the attestation result, then makes no sense whatsoever. Like if you send a request to a verifier that doesn't know anything about the attester, then the response will be meaningless.
So I will answer the two questions one by one. So first about the nonce problem. So in this case, we will let the ring party to generate a nonce. So the freshness is guaranteed by the nonce from the ring party side. So as I have mentioned, so in other draft like the attestation over EDHOs in the like group, they also propose in one scenario that the ring party can generate the nonce. And so for the different verifiers, whether they have the same policy, actually this is addressed by the verify manager. So that we will use the verify manager that recommended the verifiers that within the same with the same policy. So that for the same input of the evidence, we expect that they will generate the same attestation result. But in some cases, when they generate different results, maybe someone is get compromised, or some verifiers update its reference values, and other does not update their reference values. So we relies on the local policy of the ruling party to decide how to aggregate the different the attestation result from these verifiers.
I think there's those are good answers. I think it would be useful to write them up in a document, because the document doesn't provide that consistent story.
Yes, thank you. So we will take this mark in the update one.
Cool. Thanks a lot.
Hank's on the queue.
Yeah, try to unmute. I hope I'm at train. Again, my audio might be super awful. I don't know. I can't tell. You tell me. Yeah, maybe
you're breaking up, Hank. We can't hear you.
Because NASA isn't.
We're not getting good audio from you.
Okay, maybe try again. I can hear you well. That is unfortunate. Maybe it's better now. I should be able to.
Keep going.
Talk to you now. Okay, so maybe the NASA was a red herring a little bit, because I think this is the conceptual message flow. When I look at the slides, the conceptual message flow is the point here, not routing. And we have a lot of interesting applications of the background check model here, where you need to find suitable verifiers. And there's no real standardized solution, especially as mentioned by Hannes. There can be a lot of entities that are both providing a tester, verifier, endorsements, and reference values. So I think some consolidation here is useful. but I'm in tunnel again, so maybe I'm not audible again. But to me, the point here is that in the background check audit, especially grouping of verifiers is not only a redundancy availability feature like a round robin or some load balancing that is routing. It is more about finding suitable verifiers out there in some given scope. I mean, best case scenario internationally, globally, and very, very much standardized. But even if it's not about internet, but about a set of verifiers that are at your control, they can still be from different vendors because you have, let's say, Intel and ARM telecom verifiers, and you need to understand whom to send things to. And so these management decisions are architectural because of the conceptual message for today. It's just very, very proprietary implementation, and you could not guarantee interoperability with all your verifiers you've supplied.
Okay, queue is locked. We're basically out of time. Any response to that comment, June, or should we move on?
It's fine for me. Yeah,
Okay.
thank you.
All right, so let's move on to the next topic. So what's the name of your slides, Osama?
Sorry, again, I didn't hear that.
What's the name of your slides? I'm trying to
So
find
the
it
name
in
of
the
the
list.
slides is that, just a moment. So it should be CanRAT's architecture help in security analysis.
Okay.
Okay, perfect. Okay, so I can start. Yeah, so this is basically trying to see how RAT's architecture can be combined with different protocols. And this is, so I do not talk specifically about the protocol part because Michael was supposed to be talking about that. But anyway, so I keep the focus on the RAT side of the whole thing. So it's basically talking about the tested TLS and the RAT's architecture. And the core idea here is that can we, so we have number of years we have formally verified, like from decades we have been formally verifying as a community, I mean the various protocols, but how do we actually verify the architecture and get some formal guarantees out of it is a new thing. And that's what I pose as a question to the working group, that how far can actually the RATS architecture help in the formal security analysis of the attestation frameworks. And this is based on a joint work with Thomas Fossati, Hannes Fenisch, and Simon Frost that we have been recently working. Next slide, please. And to make it more challenging, we do not talk about open source implementations. Of course, they are easy, and not even those which are cleanly specified that we can use. So we talk about the most challenging part of the spectrum, which is that let's think about the attestation framework, which is completely closed source and which is completely unspecified, or at least very partially specified. So that's why I have DER in brackets. So it can be unspecified or underspecified. And the context for my question specifically is confidential computing. So I'm not talking about remote attestation of TPMs and all that thing. So it's very focused on trusted execution environment, and the tested TLS draft actually has it as one of the use cases already. So next slide, please. So this is really the example which is following the context that I mentioned on the last slide, which means that it's closed source. So I'm talking about SCOAN, and it's also largely unspecified, or at least I can say it's underspecified. So the entities you see here in the slide are on the left side, the workload, and on the right side, the secret broker and the verifier combined together as a configuration and attestation service CAS. And below both of these entities, You see that there is a confidential computing software, firmware, and hardware. And on top of that, there are the workload owner and the class owner. So if you see from a large perspective, very high level perspective of RATs, workload is representing the attester, secret broker is representing the relying party, and verifier as in the verifier of RATs. And Nat, do you have a question?
No, I don't. Sorry.
Okay. So then the two parties, class owner is basically representing the verifier owner in the red sense, and the workload owner is basically representing the relying party owner in that sense. And now, so this is the top level perspective of what exists in the REDs. And I argue this is not sufficient for confidential computing, at least. I mean, you could map anything in the world over to this architecture, and you could say that, okay, so we are following RFC 9334. But the real idea is that how do we actually bootstrap this system? And that's what is shown in the legend, which is the temporal behavior 1, 2, 3, and 1 and 2 are part of the bootstrapping process, which is in all of the frameworks. I don't see that anywhere specified how this actually works. And that is the idea of exploration that we started exploring, like how does it actually work? How is the bootstrap process actually being done over here? And many things are, as I said, unspecified. For instance, the process from the relying part, let's say there are now two different worlds, the RATS world and the TLS world. And from the RATS perspective, that would be a kind of a mini RATS within each of these three stages, which is like, I have shown this in the legend, the second row, which is the verifying relying party. It's a combination of the relying party and the verifier. And the arrow goes from this verifying relying party to the tester. And then after doing that attestation, it sends over that secret. So that's represented in the red. For instance, how this applies to the arrow on the right would be that the class owner, right top class owner is representing basically the verifying relying party. And the verifier, the class in total, basically complete class block is basically representing the attester. And after this attestation, it will pass on its configuration to bootstrap this class. And similar behavior happens for the other two stages. So it's not a very top level thing. So we should also go into that kind of mini architecture, what happens inside the bootstrapping process. And the third row is basically showing what roles they have from the TLS side of the thing, from the protocol perspective, who is the client and who is the server. So I will skip that protocol part for now. So focusing mostly on the architecture. I talked about the closed source and unspecified nature. So here, SCOAN actually uses three different kind of enclaves, which are quoting enclaves. One is two of them are provided by Intel, DCAP, and APID, and SCOAN has its own quoting enclave, which is SCOAN quoting enclave, and that's what I have written in the bullet beneath, which is that the functionality of that quoting enclave is undefined, and as well as the structure for that code which it will generate, that's the evidence which it generates in the end, that's also undefined. Okay, next slide, please. So I talked about the three types of quoting enclaves, and APID has reached its end of life. I think maybe the end of this year it will be finished. And SCOAN quoting enclave, on the last slide I mentioned that it is it's no longer it's unspecified, so we can't do much about that. So that third one, which is the DCAP based, is what we have analyzed in this figure and is shown here. And that's basically from the top, the third block on the left. It's actually a bit difficult without the mouse. So can I use my mouse? Is it possible from my side, or it's a bit hard to explain this way?
I don't know. You can try it.
Okay, so what should I do in order to? Should I ask to share screen, or should I?
Probably, yeah. Because I don't think you can hijack Net's mouse unless you have a zero-day exploit on.
Can you? Yeah. Does my mouse? Do people see my mouse? I don't know.
No, I don't. So even
Yeah,
if,
I don't think I have.
okay.
I don't think the presentation system lets you see mouse movements.
Okay, okay, we can just proceed like this. That's fine. So the blocks which are shown with the red dots and red outlines are basically the elements which are closed source. For instance, scone runtime in the left column, and CAS and scone runtime again in the middle column, and scone CLI on the right side. So you see that both of them are closed source. And the idea of that I specifically wanted to talk about in this is that on the top left, the application and the scone runtime are in a single enclave, which means that the measurement as a workload owner that I will get will be the combination of both of these entities and not only of the application. If I'm the workload owner, I want the measurement, I want to check my own code's measurement, right? So I do not want something else to be added to that, because that could be malicious, number one. And secondly, I do not have any guarantees. All the confidential computing guarantees are no longer very nice, because there is something added to my code and I get that measurement and not the measurement of my whole my own code. That's basically the point. And the reason why they add this is that they want minimal changes to the application, and that's why they cannot get rid of this specific element, scone runtime. I mean, so yeah, it's kind of a tricky thing. And the second thing I wanted to talk about here is that nobody actually specifies, that's the second bullet, the bootstrapping of CAS, which you see in the second column, top column. So it's again with the scone runtime. But the real problem is actually here. It's how do I ensure that the CAS was trusted, or the CAS that is doing all the verification and everything is the one which I wanted to bootstrap. So this is, I believe, the next real challenge that we should look into. Next, please. So here I'm showing very quickly about the 3 steps of remote attestation, which are the generation of the evidence. The second one is how it is conveyed over to the relying party or to the verifier, and then finally how it is appraised. So these are the 3 steps. I will not talk about the conveyance, so I will talk about generation, and conveyance is of course like the TLS part. So I will be talking about the generation and the appraisal. And the idea here is that basically, so in here, the idea is basically the same. I talked about the malicious part, that the top left of the screen, you see application and scone runtime again in a single block, that is a single enclave. And this is the same story, that basically we get the measurements of both and not the own application, my own application. And the conveyance part is unspecified by scone, which means that we do not know exactly how the evidence which is generated in step 8 is actually transmitted over or conveyed over to the relying party.
Just a time check. We have about 4 slides left and about 7 minutes total.
Okay, sure. Next, please. So this I'm done. So I only want to give an idea of what exactly should be specified when we talk about generation. And that is basically, so this is the report data which is sent as part of the request to generate that. And it's really important to specify this, because it's the one which is signed by that entity, the quoting enclave. So it's actually giving that guarantees. And the 3 of the points which I have written are mostly related to the TLS part. I will skip those. But the 4th point is that as contained, the developers of Scone actually claim that there are several properties such as state at rest which are attested. And the auth data, which is then becomes the hash of which becomes the part of the report data, has no field which is corresponding to state at rest. So we should really define when we say, or justify when we say that, okay, something is attested. So that should come with some kind of justification, that we say that this thing is attested. It should not be really that, okay, so we attest this. It should be really justifying how we actually attest this. And upon finding this, we really don't see any justification of this, because it's not part of any of the fields which you see, which will be eventually then become a part of the code. Next, please. Okay, so this is the appraisal part. We talked about generation, conveyance is unspecified, and then the appraisal part. So this is the part where we are in the stage 3. The CAS will be then verifying the remote evidence which it obtained. And the main important point I want to talk about here is in the middle block, top, which is saying Intel quoting enclave owner, S-contain, and application owner, which are the reference value providers for the reference values shown in the arrow from this entity to the remote verifying relying party at the bottom. And each of them is corresponding to, for instance, the TCP info is provided by Intel, mapping to one to with ETH, and quoting enclave identity, Intel's terms, which is from the quoting enclave owner. However, S-contain becomes a part of the reference value provider for the application measurements, because as I described on the previous slide, it's not only application, it's the combination of application plus this scone runtime. So that's really the point, that the application owner may not really be the reference value provider for his own application. Next, please. Okay, so this is the summary of the whole thing, which means that I described all the components in one of the slides, which are closed source. And this is a list of several things which are unspecified. I touched upon each of those. And it's, yeah, it's really hard to see how actually we can verify that, but we are proceeding with some of the things which we have gathered together, which I showed briefly. And if you have any thoughts on how RATS architecture could be useful in order to formally verify or even informally reason about the security of these things, so we would really appreciate this feedback. And I think the final slide, please. So I want to thank all the people who have already given us useful feedback, Nicolas, Jonat, Yaran, Thore, Hank, Giri, and anonymous ICFEM feedback reviewer. So thanks a lot, and I look forward to your feedback or any comments.
I don't see anybody in the queue. Okay, and no comments, then we'll move to the rest of the time for open mic. If there's any other topics that people want to discuss, we have 3 minutes. If not, if there aren't any other topics, then we'll move to close the meeting. Going once, going twice. I guess we're adjourned. Thanks, everybody.
Thanks for putting the meeting together.
Yes, thanks, Ned.
Yeah, thanks for the notes takers, especially.
Yeah. Cheers. Bye-bye.
Thanks, everyone.